Good evening, friends. How's everybody feeling tonight? I don't know about you, but I'm just so excited about tonight because this is definitely the topic of all topics. This is the topic that whether you go to church or you don't go to church, this is the question that literally everybody asks. Where did we come from? Are we just an accident? There's no purpose to life. Is there a design behind everything that we see, life? And so today I'm just excited about the presentation because I know a lot of people are asking those questions. How many of you have, you yourself or friends that really, ask questions about science and creation? Raise your hands. You have friends or you yourself have questions? Well, guess what? Today, we're not only going to have the presentation, but at the end of the presentation, we'll have the Q&A. And I think that's awesome, because that'll give you an opportunity to ask some questions about creation and evolution. And so, on behalf of the Victoria Seventh-day Adventist Church, I want to welcome each one of you here. We have many guests, and I see that some of you probably here for the first time. Just for fun, because we have sent 5,000 flyers in the neighborhood. How many of you are here because of a flyer that you received in the mail? Just raise your hands. We just want to know if our pamphlets are working. 5,000 flyers. All right? Not even one, okay? Not even one. So, how about Facebook? Facebook advertising. You saw it on Facebook. How about you heard it because a friend invited you or told you? Okay, look at that, okay? A lot of hands. So I think I just learned some lesson here tonight in terms of how advertising works. We welcome you folks. In addition to this presentation tonight, it just happened that Mr. Psarris, he's presenting only tonight here, but he's also part of a whole series of presentation commemorating 500th anniversary of the Protestant Reformation. So we started last night, and it's going to continue every single night. So please come back tomorrow evening as well. We have a very special topic, and the topic is about the final days. What does the Bible say about the end of the world? You hear a lot of people say even some crazy things. Well, what does the Bible say? Because sola scriptura was the saying of Martin Luther. And we're going to open the Bible and we're going to see what Jesus had to say about the end times. And are we living in the end times? That question will be answered tomorrow. And I look forward because my friend Mark Fry is going to be presenting this topic. So please come tomorrow as well, and Monday evening and Tuesday. But before we continue, I just want to thank you for just writing your name and the ticket number, because some of you are going to get some prizes and gifts tonight on the topic of creation and evolution. So we are going to give you special gifts from that beautiful table. At the end of this presentation, you can also go and purchase some. I'm sure more will be said about what type of DVDs and books you can buy. But it is my hobby personally to collect in my library books on the topic of creation and evolution. There was a time in my life as a Christian, I almost lost my faith in God because of a university professor who was very convincing to tell us students that there is no God, that evolution is the answer to where we come from. And as I listened to him, the more time I spent, the more I was questioning myself. And the professor was saying to me, I will never forget that. He says, there is no books, there is nothing on this topic. Evolution, that's science. Everything else, there's nothing else. Little did I know that there are many books and there are many scientists who believe in God. And tonight, we are going to definitely see someone and hear someone who has experienced God in his life. We're going to sing a song before we're going to give you some gifts. The song, I think, connects well with the topic tonight. It says, holy words, long preserved for a walk in this world, they resound with God's own heart, or let the ancient words impart. we believe that God is the creator of the universe, this ancient being who brought this world into existence. And maybe for some of you, this is the first time. Please, as you remain seated, we're just going to sing this song, and those of you who know it, just join us. If you don't, please hear this wonderful Christian song about our Creator. We believe that God created this world here in the Victoria SD Church, and this is our privilege right now to give you some gifts, because we just want to thank you for coming. You know, you could have chosen to go somewhere else. You could have been watching TV, Netflix, or news, but you chose to come here. Also, you could have gone to some other places. There are so many churches that I'm sure are having something tonight, but out of all these places, you came here. Isn't that amazing? That's amazing, and I just want to thank you so much. We're so excited. I wish we could give all of you gifts, all of you, but we're going to give 3 gifts today, okay? But all of you had a chance to put the numbers. So I'm going to invite somebody to bring the basket. The basket is already here. Mr. Ed or somebody, please come and help me. All right, Gladys, come and see what numbers you're going to pick from that basket. So please take your tickets, look at the number, and Gladys is going to read. Oh, that, yeah, we need to make sure everybody's there. Okay. So Gladys, you go ahead. Take one and read the number.
All right. 957. I think they'll all begin with 957. 243.
243. Raise your hand. 243. Going once. There at the back. Okay, so we have a gift, and the gift is a special DVD collection called Evolution's Achilles Heel 15. PhD scientists explain evolution's fatal flaws in areas claimed to be its greatest strengths. 15 PhDs. Man, you're going to have a PhD after you watch this DVD, okay? Thank you. So we have one more DVD and a book to give away. This one is created by the speaker himself. And this is volume 1. There are 3 volumes to the topic astronomy, volume 1. If you want to get 2 more volumes, definitely at the end you can get 2 more. So, Gladys, what's the number?
957-235.
235. Going once, Mr. Elijah. Let's give a hand of applause to this young man who is so enlightened. Okay, the DVD on astronomy. May God bless you. And spread the word. Whatever you're going to learn, just make sure you share it with your friends, okay? And finally, we have a book entitled Truth Be Told. And the subtitle, Exposing the Myth of Evolution. I'm so excited, Spike. I'm afraid I'm going to buy everything tonight from that table. It's just amazing books, some of the best books I've seen. So, Gladys, what is the number?
Okay, this is awfully close to one that we already called. 957-244.
244, going once. 244, going twice. Oh, yes. Yes. David, this is the book of all books, okay? So definitely, congratulations, I'm so glad you've got the books. Thank you for coming and joining us here tonight. Folks, isn't this exciting? All right? Every night, we're going to be giving you something special just to thank you for coming. Those of you who are watching us live, I kind of feel a little bit sorry for you because you will not get the gift. You have to come here. I know we have the best video system here, HD quality, and you're watching us on live stream, YouTube channel, but please come and join us here every night until next Saturday morning. So every night, even on Monday, even on Tuesday, we're going to be here at 7 o'clock. So God bless you. And friends, right now, I believe this is the time, we believe in this church, that all good things begin with prayer. And I would like to ask you if we could just bow our heads for prayer and ask for God's blessing for the presentation in tonight's meeting. Let us pray. Dear Holy Father, I want to thank you so much for bringing us here tonight. I want to thank you for our guest speaker, Mr. Psarris, as he's going to share not only his testimony, but his knowledge of science and astronomy. And I just want to thank you that you're using him to speak on the topic of your love all around the world, North America, everywhere, Lord. And I watched already several video clips on YouTube, and I was richly blessed. We ask for your presence here, and I pray this in the name of Jesus Christ. Let everyone say, Amen. 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 Without any further ado, Mr. Spike, welcome to the Victoria Seventh-day Adventist Church. God bless you. Lord. Thank you.
Well, thank you for having me. Thank you for coming out tonight, everybody. It's my privilege to be here with you this evening. And I know, despite the introduction, I know some of you, but most of you don't know me from a hole in the ground. So generally, I think it'd be helpful to start with that. This is me, and this is a hole in the ground. So hopefully we'll clear that up. As to why I'm here tonight speaking with you, I'm a former atheist and former evolutionist. And I'm now a creationist and a Christian. And the transformation happened in that order. I was an atheist because I was an evolutionist. And this was well into my adult years. I understood that science disproved the Bible, disproved the Creator, showed how we all got here without one, and so why would you want to believe in a Creator anyway? And it wasn't until working later as an adult, as an engineer in the U.S. military space program, that I was confronted with evidence against my atheism and my evolutionism. And after spending the better part of a year trying to disprove that, was finally forced to acknowledge that no, science actually does support a Creator. And the creation account in the Bible specifically is the true account of history. Now what am I going to do with that? So I was a creationist at that point, but not yet a Christian, because I didn't want there to be a Creator. I didn't want to be accountable to one. Struggled with that for a while, and eventually did become a Christian afterward. And I like to mention that when I speak for a couple of reasons. Number one, the other side in the creation-evolution debate, the other side that I used to be on, likes to portray Christians as being creationists because we have to be. They say because we have faith in the Bible as being true, because we have a commitment to the Bible as being God's Word, that forces us to affirm that creation is true despite what science says. And they say that if we could take off the blinders that our faith puts on us, then surely we could see objectively and see all the evidence for the millions of years, the neo-Darwinian processes, and all the rest of it. I'm one of many for whom the opposite is true. I was convinced by the evidence first, and then became a Christian afterward. Now, believing in creation is not sufficient to make one a Christian, right? Because that's the work of the Holy Spirit. I mean, there are Muslims who believe in creation. But yet, our culture mischaracterizes and misportrays this issue. Are there Christians who just affirm creation because of what the Bible says and aren't that informed about science? Well, sure. But that doesn't characterize the creation movement overall. There are many credentialed scientists who are creationists. Many of them were once atheists, as I was. And so, having been kept in darkness, so to speak, because of evolution, an evolutionary view of science, an incorrect view of science, this is my passion now, and this is why I speak on this subject. And our topic tonight is, as you can see, our created universe. We're asking the big questions. Where did the universe itself come from? Now, within the creation question, within the creation issue, there's lots of things we could talk about, lots of different topics within science, all of which are on our side. But tonight we're going to focus specifically on the biggest question of all, perhaps. Where did everything come from? And there's two basic interpretations for this. The universe was either created or it wasn't. It got there without a creator. Now, of course, there's different variations you could have of those explanations, but those are your two basic options. Now, the Bible tells us that in the beginning, God created the heavens and the earth. So this is the biblical explanation. And hopefully this is a familiar verse to us. But we are told in our culture that this is an illegitimate interpretation. We are not allowed to offer this in the public venue as an allowable explanation. Why not? Because this is a supernatural explanation, isn't it? Now the prefix super just means that which is above or beyond. So that which is supernatural is that which is above or beyond the natural world. And we are told, again, that this is an illegitimate way of looking at things. We are told that only naturalism is an allowable approach to explain the world around us. What is naturalism? Well, that's the viewpoint that only natural processes, only observable things are allowed to be used as legitimate explanations for everything. And the most popular naturalistic explanation for the cosmos today is the Big Bang model. Now, the Big Bang model says that about 13.8 billion years ago, there was a Big Bang event, which we will talk about in some detail here this evening. That Big Bang supposedly made a lot of energy, which then cooled into matter, which then condensed into gas. The gas gathered itself together to make stars. The stars gathered themselves together to make galaxies. One of those galaxies is our Milky Way galaxy. And within the Milky Way galaxy is about 4.5 billion years ago, a cloud of gas began to collapse under gravity and swirl around, and that formed the planets of our solar system. Of course, one of those planets is the planet Earth, from which we are looking at all of this today. Now, both sides of this discussion agree that indeed we are on the Earth looking at it all today. But the rest of this timeline is where the controversy happens. Now, we can actually go through every step in this process, this timeline I just showed you, and show how the evidence doesn't actually match this secular model of origins. For example, we could focus just on the solar system. And this young man here just won a DVD where I have an entire presentation just on the solar system. It goes planet by planet through our solar system, talking how each planet and many of their moons discredits the secular model in a unique way. Now that presentation is a lot of fun and I love that topic, but we're after bigger game tonight. I'm in Canada, I can talk about game, right? I see pictures of moose and such everywhere. This is great. What about stars and galaxies? Stepping back from our solar system and looking at larger structures. Can the secular model explain stars and galaxies? Well, actually, no, it can't. There's a lot of problems there, too, for those trying to deny that a creator, our creator, is responsible for it all. This evening, we're going to step back all the way back to the biggest possible scale, in a sense, and talk about the Big Bang itself. Now, this is a graphic from NASA that attempts to capture in one picture the history of the entire universe as they understand it. So this is the beginning over here on the left, and this is today over here on the right, so time goes left to right. So in the beginning, the very first thing that happened in history, there was a quantum fluctuation, which was the Big Bang. And I'll talk more about what that is here shortly. So this quantum fluctuation occurred, and the universe leapt into existence from nothing. It immediately then underwent a period of inflation. It inflated massively, explosively. In fact, multiple times the speed of light is how fast it expanded. So it expanded very rapidly for a very short period of time, but then the expansion rate decreased, and although it's continued expanding since then, it's been at a much slower rate than it was right here at the very beginning. And most of the stuff in the middle here we're not going to concern ourselves with tonight. Tonight we're focusing on this section right here, the very beginning of time itself. So basically, in the Big Bang model, the universe popped into existence out of nothing, and then again formed energy, which formed matter, which formed gas, which formed stars, and then planets, and all the rest of it. So, why do they say that this is a good model? Well, it is claimed today that this is a good scientific model, but there's lots of evidence for it. And if you ask what that evidence is, or you talk to a secular cosmologist, for example, you'll be told several things. You'll be told we have several lines of evidence showing that this indeed happened the way it is claimed. For example, we see redshifts all throughout the cosmos, and that is interpreted as evidence that the universe is expanding. What is a redshift? Well, you may be familiar with the fact that if you take a beam of sunlight and pass it through a prism, that the prism will break up the sunlight into all the various colors that it contains. Perhaps this is an experiment you did in school or something. Well, astronomers have instruments called spectrometers that do basically the same thing, they just do it more precisely. So if you run sunlight through a spectrometer, you'll get a spectrum that looks something like this. So notice here we have all the colors that the human eye can see represented in that sunlight. And there's even some light over here and over here that you can't see. The spectrometer is breaking up the spectrum into all of its various wavelengths. Now notice, as I said, all the colors are here, except there are specific ones that are missing. Specific wavelengths of light, specific colors of light that aren't there. There's these black lines here instead. What's going on here? Well, these are called absorption lines. What's happening is the sunlight passes through the sun's atmosphere on its way to us. And specific elements in the sun's atmosphere absorb specific wavelengths, specific colors of light. So those are the ones that don't make it to us. And you can actually analyze the pattern of lines within sunlight and figure out what the sun's atmosphere is made of. And this works so well, just as a piece of scientific trivia, that a number of years ago, people were looking at this and saying, well, we know what this set of lines is from, and we know what this set of lines is from, but when we subtract all the known ones, all the ones we've seen in the laboratory from experiments, there's still some lines remaining that we don't know what element that represents. So that must be a new element that we haven't even seen on Earth yet. So that was named helium, after Helios, the Greek sun god. So helium was actually discovered on the sun before it was known to be here on Earth. So again, I think it's pretty cool that we can look just at sunlight and get all this information from it. And there's a lot more besides this that we can learn, by the way. But the point tonight is, so we have this set of absorption lines. Now here's a similar spectrum taken from a supercluster of galaxies, though, instead of our sun. Notice how, again, we're seeing all the colors in the human eye that the human eye can perceive. Notice also that we're seeing a similar pattern of absorption lines in this light. That tells us that these galaxies and the stars within it, specifically, are made up of roughly the same thing that our sun is. Notice, however, though, that the pattern doesn't match up. You see how it's shifted over to the right a bit, like this. So that is known as a red shift, because it is a shift of the wavelengths over toward the red end of the spectrum. So what could cause such a thing? Well, there's several possible causes. The most common interpretation here is that it represents that the light sources are moving away from us. Because if a light source is emitting light and moving away from the observer, then the light will be redshifted. You can think of it as the light being stretched out, in a sense. Conversely, if the light source moves toward the observer, then the light will be blue shifted. You can think of that as the light being compressed or bunched up, in a sense. So by analyzing the shifts of various things we see in the cosmos, we can tell how they are moving relative to us. If something is redshifted, it's interpreted to be moving away from us. If something is blue shifted, it's interpreted as moving toward us. And the interesting part is, there are a few objects close by to us that are blue shifted, but everything else we see in the cosmos is red shifted. That tells us that with the exception of a few local objects, everything in the sky is moving away from us because we see these red shifts everywhere we look. Any direction you look in space, all the various things you see, again, except for just a few local exceptions, are all redshifted. And the farther away from us they are, the more redshifted they are. What does that mean? Well, if you interpret this as being evidence that everything is moving away from us, that we appear to be at the center of this expansion, well, you can model the universe in such a way, mathematically, that you would see that wherever you were in the universe. So if you were on one of these galaxies here, and you look today and they're all redshifted, and that means they're all moving away from you, well, that means in the future, everything will be farther away from you, because that means, in a sense, the universe is expanding. Now, here's the key point. If it's moving apart today, that means in the past, everything used to be closer together, right? So this is the situation previously. If we're here today, and everything's getting farther apart, that means in the past, everything used to be closer to everything else. Keep running that movie backwards mentally, and you reach a point where everything is at the same place. And that's the foundational idea behind the Big Bang model. The universe is expanding today, so that means in the past it all used to be closer together, and far enough back in time, therefore, it was all at the same point. I want to say in space, at the point of space. The entire universe was a point. Everything was at the same spot. So secular cosmologists will tell you the redshifts are excellent evidence for the Big Bang having occurred. Moreover, they will tell you there's two more lines of evidence. The second is the abundance of light elements in the cosmos. The Big Bang model has been modified so that it supposedly produces the proper ratios of hydrogen and helium and other light elements that we see. So they will tell you the Big Bang model matches our universe very well in terms of what our universe contains. The third line of evidence is called the cosmic microwave background, or CMB. This is a sky map showing temperature differences across the sky. It turns out there's microwave radiation coming to Earth from all points in space. And I have this little animation here to illustrate how the sky map works. So this is a very crude animation of our Milky Way galaxy. Now, of course, we're within the galaxy, so we just see the stars within it. But you can model things in such a way as if everything we see in the sky is projected onto this sphere that wraps around us. And then if you unwrap the sphere, you get a map of the sky like so. So this is a map of the sky showing the temperature of the cosmic microwave background. And it turns out that it's all very equal. First of all, the temperature across the sky is the same to within 1,000th of a degree. But the important point here is the fact that this exists at all. The Big Bang model actually predicts that there will be background radiation, sort of an afterglow from the Big Bang, all through the cosmos. This was predicted ahead of time, and then it was discovered. So this meant, therefore, that the Big Bang model is excellent science, right? It made a solid prediction. That prediction was then found and confirmed to be true. And incidentally, the discovery of this actually was the reason the Big Bang model became popular. At the time of this discovery, there were other secular cosmologies that were more popular than the Big Bang, but the other ones couldn't explain this, where the Big Bang had actually predicted it. Therefore, they were discarded, and ever since the mid-60s, the Big Bang model has been the dominant model within secular cosmology. So cosmologists will tell you that we have these three lines of evidence showing conclusively, definitively, that the Big Bang happened. We have redshifts showing the universe has expanded. We have the fact that the Big Bang can explain what's in the cosmos. And then we have the afterglow from the Big Bang that was predicted by the model and then discovered. Problem. None of this is actually proof of the Big Bang, though. Why is that? Because other cosmogonies, other histories of the universe, are also consistent with these lines of evidence. So you can't say that it proves the Big Bang over the other cosmogonies if the other ones can also account for these, right? Moreover, as we discovered more about some of this, especially the CMB, we're finding that they're not as consistent with the Big Bang as they were originally supposed to be. So the whole idea, therefore, that this is consistent with the universe, well, the Big Bang model is somewhat consistent with those three lines of evidence. And so those are the ones that are offered for our consideration. But the universe overall, though, when we look at other lines of evidence, turns out to provide a lot of problems for the Big Bang. Let's talk about some of those. Well, the first one you run into is that the universe operates according to physics. But the Big Bang model actually has some problems with this. The Big Bang doesn't match a lot of what we see from physics. For example, the Big Bang model says that in the beginning, there was nothing, and then it exploded. What exploded? Well, nothing exploded. How can nothing explode? Well, nothing can explode, and it did explode, and that's why there's everything rather than nothing. Does this make sense, though? Is this really possible? Can you really go from nothing to everything? Because think about it, nothing can create what? Nothing. Nothing can do nothing. From nothing, nothing comes. As R.C. Sproul once said, if there were ever once truly nothing, there could never be anything. Which is profound if you think about it. And as Dr. Phil Fernandez once said, you can't tell me nothing made everything. I know too much about nothing. Now sometimes people will say, well, yeah, but if the Big Bang, yeah, okay, it doesn't look good, but if you wait long enough, even something which is extremely improbable will eventually occur. Well, that doesn't help you here. Something coming from nothing is not merely improbable, it's impossible. It doesn't matter how long you wait, something which is impossible, by definition, will never occur, will it? Nor does it apply to the Big Bang anyway, because the Big Bang supposedly made four things: matter, energy, space, and time. There was no time before the Big Bang, according to the model itself. Therefore, you couldn't wait for the Big Bang to occur because there's no time within which to wait. Nor was there a place to wait anyway. There's another big problem that the Big Bang model has, in that it violates some very fundamental principles in physics. For example, if you take a physics class, one of the first things you'll be taught is a principle called the conservation of matter and energy. In other words, the total amount of matter and energy, matter being physical stuff, matter and energy in the universe is conserved. It never changes. This is sometimes called the first law of thermodynamics. So you can modify the relative amounts of matter and energy in either direction, but the total combined amount of the two never changed. What do I mean by modifying the relative amount? Well, it is now understood that matter and energy are equivalent in the sense that they're different forms of the same thing. You may be familiar with the equation E equals mc squared. E stands for energy, m stands for mass, or matter, the amount of stuff you have, and then c is the speed of light, a very large number. So this tells us that a little bit of stuff contains a whole lot of energy. So you can actually convert matter to energy, and actually you can go the other way too, energy to matter. Now the most efficient way we know to convert matter to energy is in a nuclear explosion. A little bit of stuff releases and is converted into a lot of energy. We can go the other direction too. We can take a lot of energy and convert it into a little bit of stuff. We do that in particle accelerators. We take little pieces of matter, again, I'm zipping around close to the speed of light, and smash them together. More matter comes out of the collisions than went in. And I don't just mean the number of particles, I mean the amount of physical stuff there. Now, have we created matter from nothing? No, because that violates physics. What we're doing is converting their energy of motion, their kinetic energy as they're moving around, into matter. So we can convert matter to energy, and we can convert energy to matter, but we can never create either one, because that would violate physics. And we see this principle in our lives every day. Think about this. Why do you need to eat food every day? Regardless of how difficult that process might sometimes be. Because your body needs energy. You can't make it from nothing, because that would violate physics. So you have to get it from the chemical energy stored in the food. Of course, you have to get it in your mouth first, but that's a different story. Why do you get a bill from the power company every month? Because your appliances need energy to run. Can't make it from nothing, because that would violate physics. So you have to get it from the power company, which also can't make it from nothing, because that would violate physics. It has to get it from the chemical energy stored in coal, or the gravitational potential energy stored in flowing water, or solar energy from the sun, which also can't make its energy from nothing, because that would violate physics. So it has to burn hydrogen and helium and those sorts of things. On and on it goes. This principle is very fundamental just in life everywhere. In fact, you couldn't be watching this presentation tonight if this principle weren't true, because some of the principles of electronic circuit design rely on this principle being valid. So again, we can't make either energy or matter from nothing, because that violates physics. All we can do is convert what's already there to the other form. But if you think about this, the Big Bang model violates this principle on the largest possible scale. It says all the energy and matter in the entire universe popped into existence from nothing. Well, that's a problem. This principle is so fundamental to physics that, as I mentioned earlier, if you take a physics class, it's one of the first things you'll be taught, And most of the problems you solve on homework or tests or whatever is basically applying this principle to the situation at hand and that problem and then solving it. If you ever solve a problem in a physics class in a way that violates this principle, it's automatically wrong, because this permeates physics, yet the Big Bang violates it on the largest possible scale. Now, some secular cosmologists will tell you, yes, this seems like a problem for us, doesn't it? Yes, it seems like everything coming out of nothing is a major violation of physics, but that's not really a problem, because on a net basis, the entire universe is actually nothing. Therefore, the Big Bang didn't actually create anything. And so, we're not violating physics with our model. Now, first of all, the universe doesn't look like nothing, does it? Now, they're making this claim because they say they can mathematically model the universe in such a way that all the matter and energy adds up to some large number, and then all the gravitational potential energy adds up to some other number, which is negative, and they do it in such a way that the two numbers are the same. So if you have a positive number added to a negative number, what do you get? 0. So secular cosmologists will tell you that on a net basis, the universe actually doesn't contain any matter or energy. It's nothing. That's how the Big Bang was created. Well, that doesn't actually work. And I'm not going to go to an explanation why not here tonight. If you've heard that explanation from the Big Bang side of the controversy, then you can come talk to me afterward, and I'll explain why that is not true. But for the rest of you who are interested, we're going to move on tonight. And just point out that other people say, yes, the whole idea of everything coming from nothing is a problem. So everything didn't really come from nothing. Everything really came from a quantum field. There was a vacuum, a vacuum of space, and then there was a quantum fluctuation in empty space, and that's where the universe came from. So this avoids the problem of everything coming from nothing. Or does it? Where'd the vacuum with the quantum field did it come from? That had to come from somewhere too, right? So all you've done is move your problem one step backward. Did the vacuum of space come from nothing? Well, if so, you've got the same problem you had a moment ago. And as this author points out, by the way, my quotes are from secular authors. That's probably obvious, but I wanted to make that clear. This cosmologist said, a more fundamental problem is that this scenario does not really explain the origin of the universe. A quantum fluctuation of the vacuum assumes that there was a vacuum of some pre-existing space. And we now know that vacuum is very different from nothing. Vacuum, or empty space, has energy and tension. It can bend and warp, so it is unquestionably something. And another secular cosmologist said this, from the point of view of general relativity, empty space is unambiguously something. According to general relativity, space is not a passive background, but instead a flexible medium that can bend, twist, and flex. A proposal that the universe was created from empty space seems no more fundamental than a proposal that the universe was spawned by a piece of rubber. It might be true, but one would still want to ask where the piece of rubber came from. So you see the problem so far. If the universe came from nothing, that violates physics on the largest possible scale. If you're going to say it came from a vacuum with a quantum field in it, well, since the vacuum is also something, then that raises the question, where did something come from? Did it come from nothing before that? If so, you have the same problem back again, don't you? So some secular cosmologists say, well, yes, that too doesn't work. Therefore, here's the explanation. There has always been something. There was eternally a vacuum that had the capability of quantum fluctuations, and that's where the universe came from. Well, that doesn't work either. You may be avoiding that first violation of physics that we discussed, because now you're not having anything come from nothing. Now it's always been there. There's always been something. But now you're violating a different part of physics. And this is called the second law of thermodynamics. And so, to illustrate this, I like to use coffee cosmology in a sense, to make a point here. If you have a hot cup of coffee and leave it on the counter, and you don't drink it and no one else does, what does it do? It gets cools off. More specifically, the heat within the cup goes into the room, and the heat doesn't vanish, right? Because remember, matter and energy are conserved. You can't create matter and energy, and you can't destroy it. So the energy doesn't disappear, it just goes into the room. So the room gets a little bit warmer, and the coffee gets cooler until it's all at the same temperature, right? So, if you then walk into a room knowing that that's how this works. If you see a hot cup of coffee on the counter, how long has it been there? Short time or a long time? Short time. Why is that? Because because it's still hot. If it were a long time, it would have cooled off already. Could hot coffee sit there eternally long without ever cooling off? Well, no, that's not how the universe works, right? So in a sense, hot coffee gives you a form of clock. You don't know exactly how long it's been there, but you do know it can't have been there forever. We can extend that reasoning to the whole universe. People offering this as an explanation want there to always have been something eternally. Well, the coffee analogy tells us you can't have something always be there eternally because the amount of energy is always going to dissipate. If the universe cannot be eternally old, because if it were, there would no longer be anything hot within it. And do we know anything that's still hot in the universe that hasn't cooled off yet? Stars, right? If you look in the sky and you see stars, they haven't cooled off yet. Now, every star will eventually cool off, or blow up, or be some other fate, but every star is going to go away eventually. So that means if the universe were eternally old, there would not be any stars anymore, because they all would have cooled off or blown up or whatever infinitely long ago. Now, some people would say, yeah, but you can form new ones. Well, yes, but that also takes energy, of which there's a finite amount available. That too would have been used up infinitely long ago if the universe were eternally old. That means the universe can't be eternally old, can it? Nor can there have been this eternal vacuum with the capability of creating universes, because that too, its energy would have dissipated. It would no longer be able to make anything, quote unquote. So we see then, the universe can't be eternally old, nor can reality itself, in a sense, be eternally old due to this principle, because there's still concentrations of energy within it. So combine these two principles together, and you see that any sort of atheistic cosmogony, any kind of history of the cosmos that denies God, if you're going to say that, you have to choose which part of physics you want to violate. The first law of thermodynamics says the universe can't have a beginning, therefore it must be eternal. The second law of thermodynamics says the universe can't be eternal, therefore it must have a beginning. So you have to choose, again, which fundamental part of physics you want to deny with your atheistic history. The only way out of this trap is to say there's a supernatural creator outside of the laws of physics who created the universe for his own purposes. That works fine with physics. The atheistic cosmogonies do not. So the Big Bang model, at its very core, violates some very fundamental principles in physics. It has a lot of other problems too. In fact, we won't even have time today to talk about all of them, but we will cover a few. For example, the Big Bang model says that the universe should be full of what are called magnetic monopoles, little magnetized particles that only have one magnetic pole, either north or south, but not both. Now, if you've ever experimented with magnets like in school or something, you'll know that every magnet you ever had has a north and a south pole, and if you break it up into pieces, all the pieces have two poles also, right? Remember that? The Big Bang model, though, says there should be magnets with only one pole. Now, in fact, the universe should be full of them. They've been looking for 50 years and haven't found one yet. This alone, by the way, is sufficiently challenging for the Big Bang model to be sufficient to disprove it. This is a fatal problem right here, this one alone. Another fatal problem is called the horizon problem. Turns out the universe is equal in temperature any direction we look. In fact, opposite sides of the universe are at the same temperature. That cannot be according to the Big Bang model. This too is a fatal problem for the model, all by itself. A third problem is called the flatness problem. The Big Bang predicts that the universe should have massive curvature, geometrically, either positive or negative. Turns out the universe has neither. It's geometrically flat. And if you're worried what that means exactly, it's just a geometric measure that cosmologists use. Point is, the Big Bang says massively this way or that way, but it's neither. It's right down the middle. Something which the Big Bang model says should not be, yet it is. Are secular cosmologists aware of all these problems? Well, yes, they are. These last three, they claim, however, have been solved. So let's talk about this for a little bit. Inflation says, like we talked about, that there is, first of all, this quantum fluctuation, which we've already seen doesn't work, impossible. Then, the baby universe underwent a period of rapid expansion called inflation, where the universe popped into existence and then kaboom, blew outward explosively in size, again, multiple times the speed of light, against gravity, and then the universe decided, well, it wasn't such a good idea to do that anymore, and the expansion slowed down to a much lower rate. Ask a physicist what drove this process of inflation. You'll be told it's a particle called the inflaton. Well, has anybody ever seen an inflaton? The answer is no. Is there any room within standard particle physics for an inflaton? No. Is there any reason at all to believe in the inflaton except for the fact that the Big Bang needs it to solve some of its problems? Also no. So, rather than accept the fact that the data disprove the Big Bang model, cosmologists are invoking something that's completely outside of physics in order to explain it away. Well, that's not really good science, is it? As this author admitted, what drove inflation? Well, nobody knows. Physicists have suggested different models to describe the inflating universes, but the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. So if you look into inflationary theory, I mean, it's very complicated, there's lots of math, but all it is basically is physicists writing down equations describing what the universe had to have done in order to rescue the Big Bang model from the evidence. Problem is, you can write whatever equations you want. That doesn't mean the universe actually did that, or for that matter, that those things are even possible to have happened in the first place. As this secular cosmologist said, inflation's theoretical underpinnings may be rather tentative. The inflaton, after all, is a hypothetical field whose existence has yet to be demonstrated. In other words, it's just something we made up. Its potential energy curve is posited by researchers, not revealed by observation. The inflaton must somehow have very special properties, and so on. So, in addition to these theoretical problems that inflation has, also turns out that the latest data for the CMB are causing a lot of problems for the whole idea. As this author said, the models most favored by their data, the CMB data, when combined with earlier results, suffer from exacerbated forms of initial conditions and multiverse problems, and they create a new difficulty that we call the inflationary unlikeliness problem. That is, the necessary inflaton potentials are exponentially unlikely, according to the logic of the paradigm itself. Interesting that one of the authors of this paper, Paul Steinhardt, is one of the original authors of inflationary theory. One of the people who came up with this idea in the first place is now rejecting it and is one of its most vocal critics, pointing out that it has not withstood actual evidence. As we've discovered more, the theory has been discredited. So we have something that's outside of physics, that's never been observed, that does amazing things like make the universe expand faster than the speed of light against gravity, and that is exponentially unlikely according to its own logic. What do we call such a thing? A miracle. Basically, right? You see a little hypocrisy going on here because to try to solve some of their problems, secular cosmologists are invoking, essentially, a miracle. Moreover, the Big Bang universe does not fit, I should say the Big Bang model does not really fit the universe we see anyway. The universe has a tremendous amount of fine-tuning in it. And I have a whole presentation just on this topic, which obviously we don't have time to do fully tonight, but we'll cover a little bit. Entire books have been written, for example, on how finely tuned for life the Earth is, and how unique it is in that respect. Some of these books are from secular authors, by the way. This isn't merely a matter of Bible believers talking about such things. Our sun, for example, actually, let me back up a minute. I'm not going to talk about the Earth because, as I said, there's entire books available to you. Let's talk about a few things that are typically not discussed in these circles. Who gave thanks to the Lord when they woke up this morning for having created such a finely tuned sun? Well, thank you, sir. That's very unusual, though. Usually when I ask that question, no one raises their hand. Why is that? Well, we tend to take the sun for granted, don't we? I mean, it goes up and it goes down and we go about our business. Well, it turns out, though, the sun is actually very unusual. A 30-year study of the photosphere was concluded not that long ago. They found out that the sun is essentially constant in temperature. Its energy output over the entire 30-year study varied by less than 1/10 of 1%. Now again, probably few, if any of us, We're thankful for that recently, because we don't think about such things. Partially the problem is we don't have a context for this. The context is that stars don't act this way. Stars are not these nice, quiet things that give constant energy output. Stars are typically very violent objects. You don't typically want to be orbiting around basically every star we've seen. Even sun-like stars, even the stars that are the most like our sun, as we've been looking at them and studying them, even ordinary solar-type stars turn out to have super flares roughly once every 100 years or so. What is a super flare? Well, you may be familiar with the fact that the surface of our sun is not just this smooth thing, it's very active and doing a lot of really cool stuff, which we don't have time to talk about. Well, you probably know that every once in a while in the news, they'll talk about coronal mass ejection accompanied by a large flare, and they're worried that if this might hit the Earth, it might maybe at worst affect the power grid or knock out a satellite or something. Because some of these can get pretty big. Here's the Earth compared to one of these things. You see these are large. But typically these don't affect the Earth very much. There's only been a few cases in history where there's been really much of an effect at all. Now, multiply one of these by 10 million times. That is a super flare. And sun-like stars normally produce super flares about once a century. Think about how frequently that is. Any planet orbiting around a star that's undergoing super flares, of course, not a very pleasant place to be. Yet, as this article points out, sun-like stars normally produce a bright super flare about once a century. But why a super flare has not occurred on the sun in recorded history is unclear. Well, it's not unclear at all. Go read your Bible. Isaiah 45 says, "Thus saith the Lord that created the heavens. God himself that formed the earth and made it. He established it and created it not in vain. He had a purpose for doing so. He formed it to be," what? Inhabited. So if an omniscient, omnipotent, benevolent God created the sun to sustain life on earth, or with other purposes like declaring his glory, we shouldn't be surprised that that's what it does very well. Turns out, though, our discussion of fine-tuning could actually be extended to the whole cosmos itself, the entire universe. For example, let me get ahead of myself here. A few years back, some secular scientists got together and said, what fine-tuning was necessary for the Big Bang to produce the universe we see today? And they were specifically addressing the flatness issue that I brought up earlier. The answer they got was that to produce our universe, the Big Bang had to be finely tuned to 1 out of 10 to the 60th power. That's a 1 with 60 zeros after it. So let me explain what was going on here. They realized that if the Big Bang had made a little bit more stuff, now in reality the Big Bang didn't make anything because it can't make anything, but they believe it did. They realized that if the Big Bang had made a little bit more stuff, that the early universe was very sensitive to the amount of material in it, and a little bit more stuff in the beginning would have triggered runaway gravitational collapse, and everything would have fallen into black holes, and galaxies couldn't have formed, stars couldn't form, planets couldn't form, life couldn't form, we wouldn't be here. On the other hand, if the early universe had contained just a little bit less stuff than the Big Bang supposedly made, than our universe has, is what I should say, a little bit less stuff than what our universe currently has, then there would have been runaway expansion. Galaxies couldn't have formed then, nor could stars, planets, life, and again, we wouldn't be here. So a little bit extra stuff or a little bit less stuff than what we currently see in the universe means we wouldn't be here to see it either way. The study showed that the fine-tuning this represented was 1 out of 10 to the 60th power. In other words, since there's 10 to the 80th power atoms in the universe, fine-tuning to 10 to the 60th power, which is what they discovered, meant that the window, the margin for error, in a sense, in the early Big Bang was 10 to the 20th atoms. That's the same amount of matter as a single grain of sand. In other words, if the Big Bang had made a single extra grain of sand's worth of material anywhere in the entire universe, then that runaway gravitational collapse would have happened, everything would be black holes, we wouldn't be here to look at it. Conversely, if it had made 1 grain of sand less than the universe currently has, anywhere in the universe, 1 less grain of sand worth of stuff, then there would have been the runaway expansion, we wouldn't be here. So this random event that happened without a creator, without a designer, without a fine-tuner, had to be finely tuned to a single grain of sand for us to be here. That's a pretty serious problem if you want to deny God, isn't it? Then the problem got worse. Today, the fine-tuning is up to 10 to the 123rd power. That's 1 out of this number. As this quote points out, our universe appears surprisingly fine-tuned for life, in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. Okay, instead of just throwing numbers around, let's use the analogy again. 10 to the 80th atoms in the universe, but now the fine-tuning of this allegedly random Big Bang was 10 to the 123rd power. That means that the fine-tuning, the precision, is now less than a single grain of sand. It's less than an atom within a grain of sand. It's this fraction of the mass energy of a single atom. And that scientific notation, expressed in numerical form, is this. That fraction of the mass energy of a single atom is how finely tuned this random Big Bang event that happened without a creator, without a designer, without a fine-tuner, had to be. As this very secular physicist said, this is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe somehow had to form in a way that mankind could be here. And what does that imply? That implies the creator. And you can tell what he thinks of that idea by the adjectives he is using, right? Now, the usual explanation for this is called the multiverse, saying that yes, our universe is ridiculously finely tuned, but we can explain that. Here's why. There's an infinite number of universes out there, it turns out, according to secular folks. And in an infinite number of universes, even the most unlikely one will be out there somewhere. We just happen to live in such an unlikely universe. As off the charts unlikely as ours is, the infinite number explains it. I don't want to take the time now to dig into that explanation. As you might guess, it's wrong. But if you want to hear more about that, you can bring it up in Q&A. For now, I'm going to move on and conclude this part of the presentation with a discussion of entropy. The Big Bang has an entropy problem, even far beyond the other problems that we've already talked about. So let's talk about that, if my clicker will cooperate. There we go. Let's say that everything I've talked about this evening, all the problems with the Big Bang, aren't actually problems. Let's say something actually could come from nothing. Let's say all the other problems we discussed aren't there. Turns out, even if you assume that, you still don't get today's universe when something came out of nothing. If there was a vacuum and there was a fluctuation within it, mathematically you don't get our universe from that. You get something else instead. For example, let me back up a minute. If you assume something could come out of nothing, if you assume there was a vacuum and matter popped into existence from within it, what would you assume popped into existence? You say probably particles, right? Just maybe protons and neutrons, little bits of matter. Again, this is impossible, but we're not putting that against them right now. It would be far less likely for atoms to pop into existence from nothing. Why is that? Because atoms are actually very difficult things to make. There's a force that is trying to drive the particles of the nucleus apart. There's another force that holds it together. But the one that holds it together only works over very short distances. So when a nucleus in an atom already exists, it can stay together. But if for some reason the particles get even a little farther apart, they immediately get driven farther apart, preventing an atom from existing. That's why, for example, heavier elements are unstable and decay radioactively. Like the nucleus of a uranium atom, for example, is very big. There's a lot of particles in it. And so the particles on this side are far apart from the ones on the other side. So their bond is fairly weak. So a uranium atom, for example, will spontaneously lose particles occasionally and decay into other elements. This is also why nuclear explosions are possible, because these large nuclei, the large nucleus of these things, are unstable. Not tremendously unstable, but almost there. They want to break apart, but they're barely being held together. So if you smash one of them with a neutron, they will break apart, and then it goes kaplooey. That's a technical physics term, kaplooey. So the point is, if something could pop out of nothing, you would expect particles. You would not expect atoms, because that is much more unlikely. You'd have to have the entire atom themselves pop into existence as atoms, which is extremely unlikely for particles to doing that at random. Far less then would you expect something like the U.S. Declaration of Independence to pop into existence from nothing, complete with all the signatures and so on. You may say, well, wait a minute, why not? Would be my question. If you think something can pop into existence out of nothing, then why not this? It's just matter, right? Well, you wouldn't expect it though, because it's a very specific and a very complicated and thus a very improbable arrangement of matter, right? So even though the atom scenario is very unlikely, you would still have to accept that over the U.S. Declaration scenario, because that's far, far less likely. Hopefully you're all still with me. I know you're wondering where I'm going with this, but now we'll talk about it. This is an analogy for what's happening with the entire universe if you're trying to make one from nothing. Turns out the Big Bang universe is so mathematically unlikely in terms of how improbable the early arrangement of matter had to be, that other arrangements of matter are far more likely because they're far less complicated. Even something as complicated as the human brain is actually far less complicated than the Big Bang would be. This has created a problem among secular cosmologists called the Boltzmann brain problem. The early Big Bang universe had extremely low entropy. Entropy is a mathematical measurement of probability. Therefore, the early universe was extremely, extremely improbable. It turns out that if something could pop into existence out of nothing, you're actually far more likely to get a human brain than you are the early universe as described by the Big Bang model. This is called the Boltzmann brain problem within secular cosmology. Here's an article that talked about it. It could be the weirdest and most embarrassing prediction in the history of cosmology, if not science. If true, it would mean that you yourself are more likely to be some momentary fluctuation in a field of matter and energy out in space than a person with a real past in an orderly star-spangled cosmos. Your memories and the world you think you see around yourself are illusions. You're not actually sitting in this room right now, according to this problem. You popped into existence a few seconds ago as a human brain in the midst of nothing. It's only you. Now, you may think, well, I have memories of my life up until this point. Well, no, your brain had to have the molecules arranged somehow. They just happen to be arranged in such a way that you have all these false memories built into you. Similarly, this room doesn't exist either. That's just part of the illusion. Not that any of this matters anyway, because you're about to fluctuate back into the void in a few more seconds. Going on. This bizarre picture is the outcome of a recent series of calculations that take some of the bedrock theories and discoveries of modern cosmology to the limit. The basic problem is that it's hard for nature to make a whole universe. In other words, the early Big Bang universe is mathematically off the charts unlikely. It's much easier to make fragments of one, like planets, yourself maybe in a spacesuit, or even in the most absurd and troubling example, a naked brain floating in space. Nature tends to do what's easiest from the standpoint of energy and probability, and so these fragments, in particular the brains, would appear far more frequently than full-fledged universes, or than us, or they might be us. Alan Guth, the cosmologist at MIT, and by the way, he's one of those prominent cosmologists in the world, who agrees this overabundance is absurd, pointed out that some calculations result in an infinite number of free-floating brains for every normal brain, making it, quote, these are his words, infinitely unlikely for us to be normal brains, unquote. So the Big Bang ultimately says, if you take the math to its full conclusion, which they're reluctant to do, infinite number of these free-floating, quote-unquote, Boltzmann brains for every normal brain. So the chances of you being real are of you sitting in a real room in a real universe are 1 out of infinity. What do you get when you divide by infinity? Anybody remember? 0. So the Big Bang model, if you take it to its logical conclusion, says there's a 0% chance that the universe is real. Because instead, You're just a Boltzmann brain. Now, this does not mean that you're a brain floating alone in the universe, because there is no universe. It's just you. Now, you probably think this is ridiculous, right? That's because it is. But that is what the model says. This comes out of the work of a physicist named Ludwig Boltzmann. Thus, these are called Boltzmann brains, this issue within secular cosmology. And this is a known issue. I know that some of you are thinking that I'm making all this up, but I'm not. For example, here's a paper published in the cosmological literature that says a typical observer in the multiverse is a Boltzmann brain. In the eternally inflating vacua, observers are infinitely more likely to be Boltzmann brains than honest folk like ourselves. This paper, I know you probably can't read it from there, says the most likely fluctuation consistent with everything you know is simply your brain fluctuating briefly out of chaos and then immediately equilibrating back into chaos again. This is sometimes called the Boltzmann's brain paradox. And cosmologists have been trying to solve this problem for quite some time. Avoiding Boltzmann brain domination and holographic dark energy models is the name of this one. A note on Boltzmann brains. Sinks in the landscape, Boltzmann brains and the cosmological constant problem. I like this one. Can the Higgs boson save us from the menace of the Boltzmann brains? I had to dig deep into the cosmological literature to find these papers, by the way. They don't like talking about this in public. Would you? Yeah. If this is what your model said, Boltzmann brains and the scale factor cutoff measure of the multiverse. Return of the Boltzmann brains. This was after somebody had proposed a solution and they said, yeah, that's a good idea. And they realized, wait, it doesn't actually solve it. So the Big Bang universe ultimately says the universe isn't real. Again, taking the model to its logical conclusion, which nobody really wants to do because it shows how ridiculous the whole thing is. Now, I mean, who heard about the Boltzmann brains in the last planetarium show that you went to? Or the Science Museum, or Science Magazine, or a TV show, whatever. They don't talk about this stuff, right? But that's what the model ultimately says. So what does this mean? Well, the Big Bang model ultimately says that you're a Boltzmann brain. Nothing else is real. It's just you. There is no universe. And if there's no universe, then there's no beginning to the universe, right? Which means the Big Bang never happened. So the Big Bang model says the Big Bang didn't occur. The Big Bang model disproves itself. So when secular cosmologists, when atheistic scientists think they have science to use as this great weapon against the Bible, in reality the only weapon they have is this one. Closing thoughts. Our culture likes to portray the creation issue as being religion versus science. That we have blind faith in a book and they have science, facts, data, logic, etc. No, the science is on our side, not theirs. If you actually take their models to the logical conclusion, it's totally absurd. Hopefully that's clear by now. It's not merely wrong, it's absurd. Science is on our side, not theirs. The problem is the culture is totally mischaracterizing what's going on here. And brief note, a lot of Christians think we need to use the Big Bang to justify the Bible. They say, well, science proves the Big Bang happened, and it shows that the universe had a beginning, so this is a good thing for us. It supports Genesis. Actually, no, it doesn't support Genesis. There's a lot of theological problems if you try to shoehorn the Big Bang into the Bible. Or worse, modify the Bible to fit the Big Bang model. But moreover, we don't need the Big Bang model to prove the universe had a beginning anyway. You can do that with a cup of coffee, right? Heat flow, go outside, look at the stars. That tells you the universe can't be eternal, which means the universe had a beginning. So we don't need the Big Bang model for that, nor do we want to use such an incorrect model anyway. Because in the beginning, God created the heavens and the earth, not as described in the Big Bang model, but as described in the Bible. The heavens do not declare that a Big Bang occurred, the heavens declare the glory of God. And the firmament shows the work of his hands. Brief mention of resources here. If you like the rather unusual perspective on astronomy that you've received here this evening, I have a free email newsletter that you might be interested in. It's available on my website, which I will show you in just a moment. You won't get spammed to death. It only comes out a couple times a year at this point, although I'm hoping to increase that frequency. So that is available to you. Also, as the pastor mentioned, there's a book table in back. Lots of good stuff on there. at the risk of sounding immodest after I just said it's good stuff, I do have 3 videos on astronomy. The first one, as I mentioned before, is a whole presentation on the solar system. Goes planet by planet through the solar system. Each one denies the secular model of origins in a different way, even above and beyond the stuff we talked about this evening. Very visual presentation, lots of photographs, and so on. The second volume in that series is about the formation of stars and galaxies. Where did they come from? Can the secular model account for those? No, it can't. What does the size and scale of the cosmos tell us about our Creator? And more of those sorts of topics. The third volume is what tonight's material was excerpted from, addressing the Big Bang specifically. And tonight's talk was maybe half of what the overall DVD contains. So there's a lot more information about the Big Bang than what we had time to talk about tonight. That too is available on the back table. This is my website, creationastronomy.com. That's where the email newsletter is available to you. There's a sign up right there on the homepage. And do we want to take a couple minutes for questions? Or is everybody still kind of stunned by the Boltzmann brain thing? Do we want to have a microphone to pass around? Okay, there's one coming.
I was at the University of Victoria some time ago, and they discussed similar topic as we have discussed tonight. And I asked a question at that point: what are they going to do with all the textbooks that are put out in there by the billions that still teaches about the Big Bang? Now, in your studies and your connections with people, what can you say about the topic? What are they going to do about it?
Well, if you look at how science typically works, it's usually portrayed as this smooth process where people find data and they make new theories, and then everybody dispassionately and objectively evaluates the theories, and then everybody goes with what's best. In the real world, science usually doesn't work that way. What usually happens is a theory is widely believed by most of a particular community, and as evidence against it starts to accumulate, people will start modifying the theory to account for the new information. You eventually reach a point where the theory has had so many band-aids slapped on it that some people get really dissatisfied with it. This typically has to be younger people coming into the field, because usually the older scientists have written papers, have authored books, have built a career on the old theory. So a younger generation comes in and says, wait a minute, that whole thing is wrong. We're going to start from scratch with a new theory that totally replaces the old one, and then there will be a big fight over it, and then maybe the new one will win. And typically when this happens, the old one topples generally in a short period of time. So the reason I'm saying all this is the Big Bang has accumulated a lot of advantages by this point, which is why even some people who invented inflationary theory, for example, are now turning against it. What will replace it, I don't know. But it seems pretty ripe for overthrow by this point, because it has so many internal contradictions, and it has changed tremendously since its first inception in the 60s, even though it's been true the whole time.
Well, the reason I asked that question is because are those in the scientific world going to do what the Texas government is doing right now of rewriting the history of Texas? And the same is true in the University of, I think, Ohio, as well as in Indiana, that they are going to rewrite their textbooks in reference to their own state.
Well, I don't know anything about the textbook process, but if you're asking if the Big Bang Theory is ready to be overthrown, I think it's way overdue for that. I don't know what will replace it necessarily. There aren't really good candidates right now, which is one of the reasons it's been as long-lived as it is. It's a relevant question for Christians because there are ministries out there who are pretty much based on the idea that the Big Bang is valid, and so we need to use that to support the Bible. And they've reinterpreted the Bible in some cases to try to make it fit the Big Bang better. Well, if that's your whole basis of apologetics, what are you going to do when the Big Bang model gets thrown out and replaced by something else? So trying to base your biblical interpretation on the shifting quicksand of what the scientific community might have the consensus opinion of today, well, where are you going to be tomorrow when they throw that away and go somewhere else? So I'm not sure if that answers your question or not, but yeah, the whole question of models and what's taught in the public, yeah, it's a real challenge. Any other questions?
Thank you. You mentioned dark energy and dark matter. Are they realistic, or is it just a fudge factor to make certain calculations work in favor of the Big Bang model?
Well, that depends who you ask. Dark matter is easy to mischaracterize. There are some observations on galaxy clusters, for example, where it appears that there's not enough mass within the galaxy clusters to hold them together gravitationally. We see how quickly the clusters are moving. We can estimate how much mass there is within the cluster, and so we know how much they're pulling on each other gravitationally. And it appears that there's not enough matter there to hold the cluster together. So you have two options. Number one, the cluster isn't actually going to stay together. It's in the process of flying apart. That would mean it can't be billions of years old. Your second option is, it is stable in that configuration, but that would mean there has to be a lot more gravity there to hold it together than we can account for. And that would imply there has to be more matter there. There has to be more physical stuff to produce the gravity to hold it all together. The problem is we can measure what we see and gauge how much mass there is, but it's far, far inadequate to account for the gravity you need to keep this thing together. Thus, they say there's a lot of matter there we can't see to account for this. So dark matter, the matter means it's stuff, and dark means we can't see it. In similar fashion, some galaxies, when we measure the speeds of the stars within it, the ones in the middle appear to be behaving as expected. The ones on the outside appear to be moving too quickly to stay as part of the galaxy. Now, again, you can say, well, the galaxy is just in the process of, he started leaving. Or you can say, well, the galaxy is actually held together over long term, but that again requires more matter than we can see, this time in like a halo around the whole galaxy. But again, we don't see anything there. So the secular community has focused on dark matter as this new exotic form of matter that exerts gravitational effects on everything, but does not interact with light. So it's literally invisible. Light passes right through it. It doesn't emit light, it doesn't block it, whatever. It doesn't interact with it at all. Now, such a type of matter is unknown to physics. Thus, you're invoking something outside of physics in order to explain this. Now, within the creation community, most people aren't very accepting of this proposal. There's one astronomer in particular within the creation community who's friendlier toward it. But there's other possible explanations for these observations. One option is that we don't really understand how gravity works on such a large scale. There are people who have modified the equations of gravity to produce the various velocities that we see of the stars within the galaxy or the galaxy within the cluster or whatever. So even in the secular community, there's other proposals. But the majority of people are focused on dark matter and the search for it. Now, there's been lots of searches for different proposed forms of it, all of which have failed so far. So, dark matter does have some observations that it was invented to try to explain. Dark energy, on the other hand, is more of a fudge factor, to use your phrase there. Dark energy, where the dark means, again, something that we can't see and otherwise don't know about. This was invented to explain some discrepancies with what the Big Bang model predicts for faraway objects compared to actual observations of their accelerations. If you take certain supernova observations and you interpret them with the Big Bang model, you come up with a history of the universe where it's not only that the universe is expanding, but the expansion rate itself is accelerating. So what would do that? That's, again, unknown to physics. Gravity is trying to pull all this together. It's one thing to say that it's expanding against that, but why would the expansion itself be accelerated? So dark energy is this new hypothetical form of anti-gravity energy that the secular folks is necessary for them to believe in order to keep believing in the Big Bang model. And just as an aside, dark energy is one of the reasons that the Boltzmann brain problem exists. Any atheistic cosmology actually has a Boltzmann brain problem regardless. But the Big Bang model specifically has a worse one with the infinite number of Boltzmann brains per normal brain. That comes directly out of dark energy and inflation. So hopefully that wasn't too much detail. So there is some fudge factor going on there. Dark energy for sure. Even within dark matter is based on some observations, but there's other possible explanations of it than just this new form of matter that everybody's talking about. And I hope that answer made sense. Yes, sir?
In the New Testament, we're warned not to let the Judaizers would creep into the church, and that's back in the first century in the primitive church. So what's your opinion about the idea that the Big Bang is a concept in the Talmud, and that the Talmud, the Judaizers have crept into the modern church, so that the modern Christian church accepts the Big Bang when it's an anti-Christian idea?
I didn't fully get the concept of a Talmud.
You're aware that the Big Bang is one of the prime ideas in the Talmud. Did you know
The
that?
Talmud? Oh, well, the Talmud far predates the modern Big Bang model.
Do you understand that the Talmud has the Big Bang theory as its prime idea? Did you know
Well,
that?
I mean, a lot of pagan cultures have some kind of Big Bang-ish kind of thing, but I mean, the modern Big Bang theory, I would say, is a lot more specific than some of those older ideas.
I'm asking you if you will accept that the Judaizers have crept into the modern church, the modern Christian church, and brought with them, that's where the Big Bang comes from.
That's not how I would characterize that, no. I think a lot of this thinking in the church is because people are trying to accept what they think is proven fact and make the Bible fit that. People don't generally have a good grasp of the history of science and tend to elevate scientific opinion and give it a lot more authority than it really deserves. Scientific opinion on something changes constantly. But our culture today portrays the guy in the lab coat, I mean, he's the new priest in a sense. So, and a lot of pastors have been influenced by that way of thinking. And so when a scientist says something, well, if that's the truth, then we need to interpret the Bible according to what the truth is. That's backwards. The Bible is God's word. The Bible is our authority. If scientific opinion doesn't happen to coincide with it right now, well, so much the worse for scientific opinion. Inasmuch as science discovers the truth, it will always verify Scripture because the Scripture is true. So I wouldn't call it a Judaizer issue. I think it's a lot of pastors, I should say pastors, just our culture in general has really lost sight of what our authority is supposed to be. And so, yeah, there's a lot of compromise going on in these issues. Microphone is, yes, sir.
It was on? Okay. The Bible says a darkness was on the face of the deep, and it was moved like the waters. I'm not putting it exactly. So the universe before let there be light was pure dark. Now, I have understood that matter is collapsing, and that what dark matter was God said, let there be light, and shot off electrons off of dark matter to create light. And then, so my theory is that dark matter is just collapsed matter. Is there any reason this cannot be?
Well, dark matter refers to something specifically being searched for to solve certain problems in astronomy right now. So dark matter is not something that's known in physics. It's, like I said, it's this hypothetical particle that's invisible. So I wouldn't apply that description to anything going on in Genesis. Nor do I claim to understand the first few verses of exactly what God did. The Lord did things as He did it, and I'm comfortable just affirming that. So rather than trying to apply modern physics to interpret Genesis, which almost kind of runs into the same thing that we just talked about a moment ago, I'm very hesitant to try to apply current scientific thinking to a specific part of the Bible, because current scientific thinking can change very quickly. Yes, ma'am.
Just one question to clarify. So the first law of thermodynamics is about the conservation of matter and energy,
Yes.
that we never lose one or the other. And then is the law of entropy the second law of thermodynamics?
Yes, correct.
Okay, that was it.
Yeah.
Thank you.
Yes, sir.
With regards to the Bible and the creation and the power of God, God asked Job, "Cast thou guide the path of Arcturus?" We know today that according to science, if my knowledge is correct, that Arcturus actually speeding in space 1,000 times faster than speed of light. What is the one that's controlling it other than the power of God?
There are no stars spinning faster than the speed of light. That would be incorrect. Nothing can move faster than the speed of light, because only something which has no mass can move at the speed of light. Like light itself has no mass. But to accelerate anything with mass, anything physical, to get it going faster and faster requires more and more energy, more and more of a push, if you will, to get it going. And as you approach the speed of light, the amount of energy increases exponentially. It would actually require an infinite amount of energy to accelerate anything to the speed of light. So only something that's massless can travel at that speed.
In other words, the program with CKNW, which is Earth and Skies, what are they stated in there is wrong.
I'm having trouble hearing you. Can you repeat the question?
I said the radio show talking about Earth and Sky from CKNW, the radio station.
I'm not familiar with that, I'm sorry.
But anyway, they're saying that yes, there are objects in the sky that are actually traveling faster than the speed of light. Wow. And they said that the movement beyond our galaxy is way faster than we could even imagine. And if that were true, I would say that the only reason they could be doing that is because it's the power of God controlling it.
Well, one thing they might have been talking about, the only motion faster than light in the universe is not, strictly speaking, motion through space. If you interpret the redshifts as evidence for expansion, and as I mentioned, the farther away things are from us, the more redshifted they are. That means the farther things are moving away from us faster than the closer things. You go out far enough and you will reach things that would be traveling away from us at faster than light speed. Now, we can't actually see those objects because the light isn't going to reach it to us. They aren't moving through space at faster than light speed, though. This is the universe itself expanding in between everything. And maybe that difference is a bit nitpicky. But maybe that's what they were referring to. I don't know. I didn't hear that show. But nothing that we're looking at, certainly no stars that are visible to us are moving faster than light speed. Let me ask one more question of the audience here. Yeah. Typically, one of the first questions I get is, if the universe was created recently, how can we see distant stars that are far away? Does anybody want to discuss that before we close tonight? Sure. Okay, a couple hands. Okay, so hopefully people understand why I'm asking the question. We see things that are so far away that the light would take far more than 6,000 years to get here. And if the universe is only 6,000 years old, how can we see these things? Some of these things, light would take millions or billions of years to get here. So why should we see them? Some atheists even claim this alone is enough to disprove a recent creation. Just go look outside and look at the stars. That proves creation isn't true. Well, there's actually several options here. One that a lot of people have heard about is that the speed of light used to be different in the past. Has anybody heard of this idea before? If light used to travel faster in the past, then the time to get here would be less than this calculation would indicate today, right? So this would do away with the problem. Is that hopefully clear how that would work? This idea used to seem to have some potential to it. Under further study, this idea doesn't really seem to work for a variety of reasons. So most creationists are no longer looking into this. But a lot of people have heard about it and still wonder about it, so that's why I like to mention it. Option 2 is that the Lord created light in between us and these objects as part of creation. He created the creation mature. Adam didn't wake up as a baby or an embryo. He woke up as a man. He didn't wake up next to a pile of fruit pits and acorns and seeds. He woke up next to fruit trees, right? fully functional. So in similar fashion, perhaps God created a functional universe which included beams of light in between us and those various objects. Now, some people don't like this explanation because they think it would make God a deceiver. For example, we see supernova explosions. Some of these, this by the way is a star that blows up. In some cases, we've actually seen the star before it blew up. So people say, well, if there's this light beam that God created, and for example, there was a supernova in 1987 that was 168,000 light years away. So this light beam had to be 168,000 light years long. But we saw a star there until 1987, roughly 6,000 years after creation, more or less, almost. So that means the first 6,000 light years of that beam had the image of a star in it. And then it had the image of an explosion in it. The image took 6,000 years to get here, in 1987. And then behind it, we're seeing an expanding ring of gas after the explosion. And so presumably that's what the rest of this light beam is going to show us. So do you understand what would be in the light beam then in this scenario? But the issue is, there was never a star on this end of the light beam. The star never existed. The star was only an image in the first 6,000 light years of the beam, and then there was an explosion image which also never existed, and so on. So some people think the mature creation idea makes God a deceiver. I don't think that's the case. I don't think that would make God a deceiver, because if the Lord tells us when he created everything, it's not deceptive. Adam wasn't deceived by the fruit trees, was he? The fruit tree looks at least 5 years old to make fruit, let's say, but Adam didn't think, wasn't deceived by that, because the Lord told him, no, I made these 3 days ago. So mature creation is another option for this problem. Then there's other more scientific solutions. And I have a whole presentation just on this, but I'm going to limit this just to one option, which is time dilation. What does that mean? Well, Einstein's relativity has some interesting implications, as you probably know. One of them is that gravity affects time. So the deeper you are in a gravitational field, in a gravitational well, the slower time flows for you. And we verified this experimentally. For example, in the US, we have several atomic cesium clocks. There's one at sea level in Maryland, and there's one a mile above sea level in Colorado. The one at sea level ticks a little more slowly. Atomic clocks don't really tick, but it's measuring time more slowly than the one a mile above it in altitude. Why is that? Because the one at sea level is further down inside the Earth's gravitational well. Now, the difference between them isn't much, but it's measurable, and it's exactly what Einstein predicted. In similar fashion, the GPS satellites, which I'm showing you here, are obviously higher above the Earth than we are. Time flows slightly more quickly for them up there than it does for us down here. And the satellites actually have to account for this difference in their calculations. I got to see the GPS design documents at one point when I was working with the people who were flying. So GPS has to account for this relativistic effect. If it didn't account for it, then its calibration with our clocks would drift over time, and eventually GPS wouldn't work anymore. So my point is, Einstein predicted gravity affects time. It seems weird, but we've verified it experimentally, and in fact, some of our technology has to account for this, because it's a real effect. Okay, so why am I talking about it? Because of verses like this. Isaiah 42 says, "Thus says God the Lord, who created the heavens and stretched them out." So a few years back, a Bible-believing physicist was reading one of these passages that say similar things. I don't remember if it's this one or not specifically, but he said, God stretched out the heavens. Is that poetry, or is it literally what happened? If it's literal, what would that look like? So he figured, let's say the early universe, God created all the matter of the universe in a very small volume, a very small region of space. Let's say it was small enough that everything was dense enough to have gravity strong enough that it would be a black hole. Okay, so right at the beginning, God created the initial matter of the universe. It's still formless and void at this point, and it's in a black hole. Now, this dotted line here represents the event horizon of the black hole. So this is not a physical thing, it's not a shell, it's just a distance. The event horizon distance from the center of a black hole tells you how wide the black hole is. So in here is black hole effect, all the black hole weirdness happens, and out here is normal. So, this is how God created it. Now he starts stretching. As he's stretching, the volume increases, which means the density decreases, which means the strength of the black hole decreases, which means the event horizon, that distance, starts to shrink. Now within this, God is starting to form things, galaxies and so on. He continues stretching. Eventually, the universe gets large enough and the black hole gets small enough that some of the universe is now outside the black hole, while the rest of the universe is still inside. And we're still in here, by the way, roughly toward the middle of that. Here's where it gets interesting, because this relativistic time effect that I'm talking about means time is flowing normally out here now, but inside the black hole, time is almost stopped, because that's how black holes work. So time is now flowing more rapidly out, much, much more rapidly, by the way, than it is inside. And again, the Earth is still in here at this point. So God continues creating things, continues stretching. Again, time is now flowing more rapidly out here for a larger region of space because the black hole is getting smaller, but in here, time is still close to being stopped. It's hardly ticking at all. God keeps expanding and stretching the heavens until eventually the universe is large enough, which means the density is low enough that the black hole is gone. No more black hole anywhere. Well, there's small local ones left over, but that's not what we're talking about. So today, now that this massive black hole in the middle is gone, time is flowing the same everywhere, except for local variations, like if you're next to a star or planet or something. But overall, time is flowing at the same rate. But what has happened until this point? Lots of time has passed out here, where very little time has passed here. So you could have millions or billions of years passing out here, which gives time for galaxies to collide and some other stuff that we see going on in space that would seem to take a long time. And there's time for light to come from out here into here. While meanwhile, a clock here only measured 6 24-hour days. So if you ask the physicist who realized that relativity had this implication for a creation cosmology, if you ask him, how old is the universe, he'll say, according to which clock? Because which of these clocks is correct? They all are. They all correctly measure the time in their local region of space, in their local environment. But the one out here measured a lot more time than the one here did. Here measured 6 days of creation, and then a 7th Sabbath. And what has happened now today, what has happened since then? Well, 6,000 years later, so this one is now 6,000 years more than it was, and that one is 6,000 years more than it was, but that one had a whole bunch more on it to begin with. But you understand the point here. Different clocks in different parts of the universe will flow at different rates, depending on how the mass was distributed. So this explains how light could get here, along with some other issues related to that question. So hopefully that is helpful. But there's other possible solutions than this one. And by the way, the physicist who came up with this has since taken the idea in a little bit different direction than how I just described it to you. But I like using his first model because hopefully it's clear, and it shows how the different clocks flow at different times.
All right.
Thank you very much for your attention.
Folks, on behalf of our congregation, Spike, thank you so much. You know what? Before you go, a very nice song that Gladys was just about to sing. I just wanted to ask you here. You mentioned you were an atheist. This is the last question for you.
Okay.
You were an atheist and you became a believer.
Mm-hmm.
What evidence specifically gave you this aha moment when you said, "Wow, now there must be God"? Is there any? Was it the fine tuning, or was it the physics? Is there anything where maybe it's everything that just dawned on you and you said, there must be God? When did it happen to you? And what?
It wasn't one aha moment. It was a series of oh no moments. Because I was trying to disprove creation. That's how I got into all this. I was working with a man who I found out was a creationist, and I was kind of shocked. I mean, he's a smart guy. He's there working with us, but he believes this stuff. I said, how can you deny all the obvious evidence for evolution? He said, what obvious evidence is that? So I started challenging him on fossil sequences and age of the Earth and radiometric dating and all these things, and he shot it all down. This is a series of conversations over a long period of time, over lunch and whatever as we have time. And so I'm challenging him, and he keeps answering all my questions, and I start looking at the stuff he's saying, and he was right. Eventually, after a while, I ran out of things to ask him, and so he says, okay, I answered your questions, you can answer mine. That's fair. He says, you believe in the laws of physics, don't you? And I said, we use them here every day, sure. And he said, how do you reconcile those with the Big Bang model? So when I thought about the question, because he didn't explain what he meant, that's when I first realized, wait a minute, first law of thermodynamics, second law of thermodynamics, and all these other problems that the Big Bang model doesn't play well with physics. That's when it got personal for me. So that was a seminal moment in a sense. Up to then, it was me having fun trying to, batter him with questions. Suddenly I realized I have a problem with my worldview. Now I gotta fix this. So that really launched me on a big research project, A, to disprove what he was saying, and B, to find justification for what I believe. But as I'm digging through my textbooks and all the rest of it, I'm seeing these huge holes in the reasoning. I'm saying, how come I never noticed this before? I mean, here's the math, and then they go, we shrug, we don't know this part, and then they go on with the math again. You can't do that. And meanwhile, I was going for a master's in physics at University of Colorado at night, and as I'm sitting in physics classes, these are not creation classes at all, but because of my daytime conversations, I'm sensitive to origins questions. We're studying things like orbits and astrodynamics and other stuff, and I'm realizing, well, if this math is correct, and I know it is because I just did it, then this means there's big problems in, for example, the solar system. The solar system can't have formed the way they claim because this says that's impossible. And I go look things up in the solar and planetary science stuff, and sure enough, that doesn't work either. So I eventually ran out of places to go in astronomy. I said, okay, astronomy's all pointing the wrong way. What about biology? Sure, there must be evidence for Darwinian evolution over millions of years, etc. Well, I dug into that. That didn't work. Geology didn't work. Paleontology didn't work. Then my friends started bringing in books about the historicity of the Bible, evidence that the Bible is accurate and that we have reliable manuscripts and copies of it today, that we know what the original authors wrote, that there was a man 2,000 years ago named Jesus who died and rose again, and overwhelming evidence for that, and I was evidence for a global flood and all this stuff, and after almost a year trying to disprove all this, I had nowhere else to go after a while. I was like a cornered rat. All the science is pointing the wrong way, so at that point I said, okay, creation's true, but I don't want it to be true, so what do we do? So that's that in a nutshell. There wasn't a one moment I can point to. It was almost a year of research trying to disprove it all before I finally had to say, I give up. So,
Thank you, Spike.
thank you.
Once again, thank you so much. I don't know about you, but Spike, when you eloquent speaker, you speak fast, and some of it sounded like Greek and Hebrew to me, but at the same time, you tried, your best to explain it, and I tried to make a list of all the arguments, but it was very clear. Thank you so much. And but in all of the things that you've said, I just realized how little we know about our universe. I think I remember one scientist who was asked the question, how much do we know? And he said something like less than 1% out of 100% of how much more there is to know. So there is a song, God and God alone. And this is what Gladys is going to sing. Let us just pay attention, and then of course we'll have a prayer, and then you can ask questions of Spike. Spike, you will be able to take some more questions, and probably you'll be there at the desk with all the books. So Gladys, lead us in this song, God and God alone.
I just wanted to say, Spike, that everything that you said tonight is wrapped up even in the title, God and God alone. Created
Heavenly Father, thank you so much for gathering us here. Thank you for Spike and his presentation. We definitely learn a lot, and I just feel so little compared to your glory and your power. And at the same time, Lord, I feel like it will take eternity just to get to know you. And we thank you that we have been carefully and wonderfully made in your image. We thank you for that. And now we ask for traveling mercies, and may we see each other again. I pray this in the name of Jesus Christ. Amen. God bless you, folks. Remember, we continue tomorrow evening at 7 o'clock. But I think, Spike, there's people that want to talk to you. I already spent a lot of money, I have to confess. I have bought a whole bag. I think this is some of the best books. I spent over $100. And if you didn't bring cash, there's machine, debit, Visa, everything. And I just want to thank the Creation Science Ministry of British Columbia. There are several people here representing. I want to thank the posties from Nanaimo for setting us up. And I hope that we can work together in the future on these projects. Thank you. God bless you. And there's a whole table waiting for you. God bless.